using the rational zero theorem, we can make a list of the possible rational zeros of any polynomial. All we need to do is find all the factors of the constant term and divide that by all the factors of the leading coefficient. So let's figure out the factors of the constant term first. So factors of 18. Well, 18 is a factor, 9 is a factor, 6 is a factor, 3 goes into 18, 2 goes into 18, and of course 1 goes into everything. Let's divide that by all the factors of the leading coefficient. So the leading coefficient is 3. The only other number that goes into 3 is 1. Now we want to consider all the positive factors as well as all the negative factors. So we want to think of this as plus or minus out here. We're going to take each number in the numerator and divide it by every number in the denominator. So 18 over 3 is plus or minus 18 over 3, 18 over 1, plus or minus 9 over 3, plus or minus 9 over 1, plus or minus 6 over 3, plus or minus 6 over 1. Now let's go to 3. Plus or minus 3 over 3, plus or minus 3 over 1, plus or minus 2 over 3, plus or minus 2 over 1, and plus or minus 1 over 3, plus or minus 1 over 1. Once we have a list of all of the factors of the constant over all the factors of the leading coefficient, we can clean this list up a little bit. 18 divided by 3 is 6, so plus or minus 6. 18 over 1 is 18, so plus or minus 18. 9 divided by 3 is 3, so plus or minus 3. And then 9 divided by 1 is plus or minus 9. 6 divided by 3 is 2, so plus or minus 2. And 6 divided by 1 is 6, but we already have 6. We don't need to write it again. 3 divided by 3 is 1, so we're going to include plus or minus 1. 3 divided by 1 is 3, but we already have it, so we don't need to write it again. 2 divided by 3, plus or minus 2/3. 2 divided by 1 is 2. We already have that. We do not need to write it again. 1 divided by 3 is plus or minus 1/3. And then 1 divided by 1 is 1. We already have that, so we don't need to write it again. Here is the complete list. Now, often books or maybe your My Math Lab will ask you to write this in descending order, but that's fairly easy. I need you to understand that these are only possible. That does not mean that all of these will be zeros or roots to your function. Let's talk about real quick little reminder about real numbers and how that is on a graph. Real zeros are your x-intercepts. However, there are complex zeros that include imaginary numbers, and those will not be x-intercepts. Real numbers include rational, which is what we found here, and irrational, which is square root of 2 or pi or square root of 5, non-repeating decimals. One last reminder, the degree of your polynomial gives you the total number of zeros, and that includes both real and imaginary, including repeated zeros.